Tempelos. This operating system was created by a single programmer, Terry A. Davis, who spent over a decade building it from scratch as a digital temple to commune with God. It features a rigid 640 by 480 resolution, a 16-color display, and its own unique programming language called HolyC. While it lacks networking capabilities and modern graphics drivers, the system is technically impressive because Davis coded the entire kernel, compiler, and graphics engine completely by himself.
Let's be clear, I'm literally the smartest programmer that has ever lived, okay? Look at this shit. Look at this. Fucking sprites, command line, flight simulator. The smartest programmer that has ever lived, okay?
It remains a fascinating artifact in computing history, celebrated for its raw complexity and the tragic, singular vision of its creator. ReactOS, this entire operating system, is written completely in assembly language, allowing it to fit entirely on a single 4 megabyte floppy disk. Despite its incredibly small footprint, it boots almost instantly and features a full multitasking graphical user interface, audio support, and even basic games. Developers love it because it demonstrates just how efficient software can be when you strip away decades of bloated code layers. It serves as a masterclass in assembly programming, proving that modern computing power often masks inefficient software design. Haiku. This open source operating system is built specifically to continue the legacy of BOS, a multimedia-focused platform from the late 1990s that briefly competed with Apple. Unlike Linux or BSD, it is written from the ground up for personal desktop computing, focusing heavily on responsiveness, low latency, and efficient media processing. The system uses a unique file system that indexes metadata like a database, allowing users to find files almost instantly. It matters because it offers a glimpse into an alternative evolution of desktop computing, free from the architectural baggage of Unix or Windows. Plan 9 from Bell Labs. This research operating system was built in the late 1980s by the same legendary team that created Unix, intending to fix the structural flaws of their original creation. It takes the everything is a file philosophy to its absolute extreme, treating networks, hardware components, and processes all as standard files that can be manipulated through a unified protocol. While it never achieved mainstream commercial success, its concepts heavily influenced modern technology, particularly the development of the UTF-8 character encoding and various virtualization systems. Amiga-OS. This system powered the Commodore Amiga computers in the mid-1980s and was decades ahead of its time regarding multimedia and multitasking. It combined a command line interface with a sophisticated graphical user interface called Workbench, allowing users to run complex graphics and audio software concurrently with minimal memory. The platform developed a massive, fiercely loyal community of artists and musicians before Commodore went bankrupt. Today, a dedicated group of developers and hobbyists still maintain and update the system, keeping its unique architecture alive on modern, specialized hardware. ReactOS, this open source project, aims to create an operating system that is completely binary compatible with applications and drivers written for Windows NT-based systems. It is not a Linux distribution with a Windows skin. The team is literally reverse engineering the core Windows architecture from scratch to let you run PC games and Office software natively without buying a Microsoft license. Progress is notoriously slow due to the sheer complexity of the Windows ecosystem, but it represents a vital effort to ensure digital preservation and software freedom. Serenity OS. This modern desktop operating system started as a personal therapy project by developer Andreas Kling in 2018, designed to look like a 1990s user interface, but function with a modern Unix-like kernel. Every single line of code from the web browser to the window manager and core libraries has been written by hand without relying on third-party frameworks. The project has grown into a massive collaborative effort with hundreds of contributors worldwide. It stands out in the tech world because it rejects the modern philosophy of software reuse, proving that a community can still build a fully functional ecosystem from scratch. Kontiki, this ultra-lightweight operating system, was developed to run on extremely resource-constrained microcontrollers, often possessing just a few kilobytes of memory. It introduced a concept called proto-threads, which allow for multi-threaded programming style while consuming virtually no memory overhead. Because it includes a full network stack within such a tiny footprint, it became a foundational technology for early Internet of Things devices and wireless sensor networks. It matters because it expanded the boundaries of where an operating system could actually exist, paving the way for smart infrastructure.